Yes, the dulcet tones of Windows 95. It's like shoving warm butter into your ears, you know what I mean? Or is that just me? And it's not just nostalgia speaking, Windows 95 was genuinely a huge milestone in the world of home computing. There's a reason so many people have fond memories of it. It was basically the first OS that mere mortals could actually use and afford. Plus, just look at all these attractive people using it. This could be you! Coupled with a lot of technological advancements occurring at the same time, Windows 95 stood at the forefront of a very exciting time for personal computers, and solidified the Windows-dominated world that we live in today. Honestly, why did we ever upgrade from Windows 95? I can still browse the internet, check my emails, and write Word documents. What more do you need? And it doesn't spy on me either. You know what? Reject modernity, embrace 30-year-old versions of Windows. That's why. Yeah, it might have been the most usable mainstream OS of its day, but that's not saying much. Windows 95, especially in retrospect, was, there's no other word for it, clunky.
McClunky.
Even Microsoft was aware of this to an extent. At the exact same time they were developing Windows 95, they were also developing from scratch a much more modern OS called NT, an OS with none of the foibles that come from being based on something originally called Quick and Dirty Operating System. But NT was far too resource hungry for the average home computer at the time, and like it or not, its lack of full DOS compatibility would have been a significant problem for a lot of regular computer users. We did eventually get the benefits of NT at home in the form of Windows XP. We just needed a stopgap while the rest of the world caught up. So if Windows 95 wasn't even the greatest operating system at the time, why are we still talking about it? Well, clearly I don't have much else going on. Us nerds just enjoy reliving computer history, no matter how primitive it all used to be. Normal people might like talking about ancient Rome, but this was our assassination of Julius Caesar. And the one thing we like even more than that is running new stuff on old stuff. Ever see Super Mario 64 on Windows 98? Or a newish version of Firefox on Windows 2000? It may not have a lot of practical use, but man is it satisfying seeing these old dogs do new tricks. So what happens when you're in the situation, which I'm sure a lot of us have been, where you need to write a new app for Windows 95? What are even your options?
Alright team, by which I mean one guy. So I've gone over the new project, but the client has made a special request. They want it to run on Windows 95. Yay. So what are our options? Well, it's Windows, right? Surely we can just use the Windows API.
Ugh, the Windows API? That thing's a mess. Have you ever seen how much code it takes just to make a window that does absolutely nothing? Come on. Do you really hate yourself that much?
Maybe not that much. What about that Microsoft Application Framework, MFC?
Yeah, maybe. But what was the last version of Support 95? Like 4.2?
Something like that.
It's pretty old. The only official way to make the UI is going to be this clunky old IDE that barely even runs on modern Windows. Can't we use anything more modern?
More modern? I guess that rules out Delphi too.
Delphi? What do you think we're all going to put up with Object Pascal for the next 20 years? Come on. Use your head, idiot.
Okay, well how about that newfangled one, WX Widgets?
Oh god, don't get me started. WX Widgets? The one that says it works on 95 but actually just doesn't? Besides, haven't you seen all the stuff moving away from WX Widgets and towards Qt?
Cute.
Yeah, you know, Qt.
Oh, you mean Qt? No?
Pretty sure it's pronounced Qt.
I'm not calling it that. Oh, but you're okay with calling it Qt? That's besides the point.
First of all, the last version of Qt to support 95 was Qt3, which is already several versions behind. Secondly, you'll never be able to find a copy of the builds anywhere. Apparently their Windows builds were only part of their commercial tier and they've never been republished, so as far as I can tell, they've effectively become lost media. Sure, we can compile it ourselves with the help of patches from some guy on SourceForge, but even then, on Windows 95, it only barely actually works. The text is all screwed up, Windows can't be resized or maximized, which especially sucks when one opens looking like this, and there's no one to report these issues to because no one's maintained this stuff in about 20 years. Alright, you've made your point. Qt would be a pain in the ass.
Qt.
Whatever, alright? Do we have anything else?
23-year-old version of Java?
So let me get this straight. We've got like 6 options and all of them suck.
Yeah. No wonder everything's a fucking website nowadays.
There might be a better way. Maybe. In the early 2000s, Microsoft introduced .NET, which, confusingly enough, has almost nothing to do with the internet. Nor does it have anything to do with cars like this commercial suggests. But to be fair, even I found it challenging to know how to visually represent .NET. It's not like it has a UI, and there are only so many times you can show the same logo. So to solve that, I'm just going to show pictures of this guy instead. What .NET really was a response to Java, which had gained a lot of traction for being both easier to write than C or C++, and completely platform independent. Write once, run anywhere was Java's slogan, and it didn't take long for the idea to catch on. Microsoft responded by making their own easier version of C++ called C#, and they too made a whole platform-independent, write once, run anywhere infrastructure that they then only released on Windows. Since then though, Microsoft has become a little less, well, evil, and today .NET is available on more or less everything. Its primary language, C#, frequently ranks in the top 5 most popular languages, and it's become essentially the de facto way to write modern Windows apps. Well, it all sounds great, doesn't it? If only we could get this on Windows 9X. Well, actually, you can. Visual Studio, even today, still supports writing apps for .NET 2, and .NET 2 supports everything from Windows 11 all the way down to 98 2nd edition. Yeah, you can actually write 98 apps with the latest Visual Studio. But what about Windows 95? What about the king that ushered in the Windows revolution? Well, no. Even .NET's earliest versions never supported 95. Well, why not? Is 95 really that much more primitive than 98 and NT4? I mean, they all look and feel pretty much the same. What is the difference between 98 and 95? Well, for the record, the answer is 3, but other than that, I'm not really sure. 98 definitely feels more refined, and that's mostly how it was marketed, as a tune-up to Windows 95. It did introduce a more stable driver model, and it had built-in support for USB, but how do either of those affect the ability of .NET to run? I know this was 2002 and Windows 95 was 7 years old, but technically, Windows 10 is older than that today. I needed answers, so I went to the one place I knew I could find some. The streets of Los Angeles. Why was .NET not released on Windows 95?
What is .NET again?
You ever get the feeling you're in a bit of a niche? There is actually an answer to this, but it comes in the form of an old Usenet thread from 2001, back when .NET was still in beta. Chris Crabtree tries running .NET on Windows 95, only to find that it says it doesn't support it, despite apparently finding some documentation to the contrary. Rusty Miller, a Microsoft employee, confirms that Windows 95 will not be supported by .NET. When Chris expresses his disappointment, another Microsoft employee, Lance Olson, spawns in to explain. There's a lot of corporate soft speak here about quality assurance, deadlines, and customer satisfaction, but essentially it all boils down to they didn't think it would be worth the effort.
And to an extent, they were probably right. I mean, according to stats collected by W3 Schools, Windows 95 had a whopping 0.8% market share around the time .NET was released. Now, it's probably a little higher for the general population. W3 Schools has a, let's say, technical demographic. But still, if you were Microsoft and you were making something this complex, even I'll admit that it would be hard to see the point.
Still, that doesn't help me or my good friend Chris Crabtree, or anyone else who wants an easier way to write apps for a nearly 30-year-old operating system. That being said, Lance Olson does admit something that we've suspected this whole time. Technically, he says, there are not a ton of differences between Windows 95 and Windows 98, but there certainly are some, and we can't just assume that they won't have an impact.
Now, back in the day, telling Windows 95 users to upgrade was probably not bad advice in general. But today we're not using Windows 95 as a daily driver. At least I hope you aren't.
Our goal today is just being able to run new stuff on old stuff, and from that perspective, getting a whole new app framework on 95 makes a lot of sense. Not only would it make it easier to write new stuff, it would theoretically backport a ton of existing stuff too. According to GitHub, at least a few thousand repositories using this version of .NET. Microsoft may not have been willing to smooth over the gaps between 98 and 95, but they also admit that there aren't that many gaps to begin with, so you know what?
Fine. I'll do it myself.
So I finally decided to plunge in and give it a shot. I mean, how hard could it be? So, what's the deal with backporting? Well, like a lot of things, it's actually pretty simple, at least in theory. If you're writing a program, you may wish to use a fancy, newfangled function from the Windows API. Let's say something introduced first in Windows 10. Backporting is essentially just not doing that, finding ways to achieve the same result, or something close enough, using only older system calls. It's kind of like Windows is your office janitor, you know? And backporting is like saying to him, no thanks, I'll clean the toilets. You start to get a feel for why companies don't do this very often. Imagine trying to explain to your boss, yes sir, I could have had this done within budget and on schedule, but I chose to accept less help. Why? I really wanted to see it run on Windows ME. Alright, so .NET is going to expect certain help from the operating system that Windows 95 is not going to be able to provide. So all we have to do to get it running is find other ways to do what .NET wants. To test our work, I'm using an old version of a tool that mods some obscure game called Lego Island. Never heard of it, but whoever wrote this tool ended up rewriting the whole app in MFC specifically to support Windows 95. But what if they never had to? Let's find out. Now, it's one thing to rewrite code when you have code to rewrite, but how are we going to do this with something that's closed source? Well, welcome to part 1 of decompiling .NET. Okay, no, I'm kidding. We can actually do this without touching .NET's code at all. You see, applications communicate with Windows through an array of DLL files, and there are many ways to shove our own DLL in between, with which we can do just about anything. Intercept, modify, or even replace calls entirely, or add those missing calls that the original program expects. Is that a good way to write a virus?
Yes, it is!
Something you might be thinking is this sounds a lot like Kernel X, a compatibility layer that allows apps for Windows XP and 2000 to run on 98 and ME. It's really cool and does work for a lot of things, but not for Windows 95, so we're on our own here. Not the first time an X has left me on my own, am I right, ladies? Yeah. Now, thankfully I'm not trying to write something as all-encompassing as that. Technically, I'm only focusing on one app that runs a bunch of other apps, so that means I only have to worry about what it uses explicitly. Speaking of .NET, how do we actually get it installed on this bad boy? Obviously, it won't be as simple as just running the setup. In fact, even the installer complains about missing Windows APIs. Damn. And honestly, I wasn't all that invested in running the installer. Chances are, with the amount of modifications I'll have to make to .NET, it'll probably be worth just making a new installer that makes those modifications automatically. So what's the main thing an installer does? Well, it puts files on the hard drive, and thankfully there are a lot of easy ways to extract files from Windows installers. So I just threw the files into the right places on Windows 95 and tried it out to see what would happen. Exactly what we would expect. If an app has a hard dependency on a function Windows can't resolve, it'll refuse to even start it, and weirdly complain about a device not functioning. But this is where we come in. Using a tool called dumpbin, we can list everything it needs, so now we just have to grind through adding whatever's missing on 95. The dumpbin? What is this, my house? This will cover most of it, but not all of it. There are ways to call system functions that fail much more silently. Case in point, one DLL wouldn't throw any error message at all. Instead, .NET would attempt to reload it infinitely, overflow the stack, corrupt the memory, and crash the entire computer. Cool. For the record, that wouldn't actually have been possible on NT or any modern OS for that matter. Only 9X allows a single app to corrupt the entire system's memory, one of the many reasons why we don't use 9X anymore. But really, that's all this was, making fake system DLLs for .NET to talk to, passing through the calls that did exist on 95, and adding the ones that didn't, which was really only about 20 or so, and honestly, I'm pretty sure most of these never even get called. Now, how can an app have hard dependencies that it doesn't even use? Well, if you compile something with Visual Studio, by default it links a few standard libraries into your app too. This means it'll inherit all of the dependencies of those libraries even if you never actually use any of that stuff. That's why even a simple Hello World app built with the latest Visual Studio won't run on Windows 95. You have to disable any default libraries and only add what you need. Again, assuming you only use stuff that is on 95. It's like I'm just trying to hello world here. Where did you get this from? Why are you carrying this around? So I have to admit, if I never saw a function actually get used, I just left it blank because it didn't matter. For the ones that did get used, they were actually really straightforward. I thought I was going to have to steal code from Wine for these, but honestly it was all pretty obvious what each function needed to do just from the name or description. There were things that realistically couldn't be implemented on Windows 95, they just had no relevance or support at the OS level, but for those I could get away with just faking the results without causing any adverse effects. Eventually I'd worked through all of these system calls and added some registry entries it asked for, and for a lot of apps that would have probably been sufficient, but not here. In fact, now when I'd open an app I'd get nothing. Well, at least it's not an error message? Progress? Well, I got my DLLs to produce some logs so I could see not only if and when it was calling my hacked together code, but also if they, or any other system calls for that matter, were failing. And I soon found one that was, though it wasn't actually one of mine. Yeah, so just because a function exists in Windows 95 doesn't mean that it works the same way as it did later on. It's kind of like puberty, you know, old stuff has new functionality. Well, anyway, that's the end of my set. Goodbye, everyone. Seriously?
So I guess I don't have a career as a stand-up comedian. It's okay, I'll go console myself with that new movie. I heard it's pretty therapeutic. Besides, at least I went on now. Yeah, the guy from Seinfeld's going up next.
The computer, a brilliant tool for anything from equations to communications. An electronic tool like never seen before. Something so powerful it can even work with letters and words. Watch what happens as Clive here pushes a key on the keyboard. As you can see, that very same letter appears on the screen like magic. But the computer does not speak a language like you or me. The computer speaks in numbers. In order to produce human-readable words, the computer needs a way to relate those numbers to letters and vice versa. This is called an encoding. For decades, different people speaking different languages would use distinct and largely incompatible encodings. This was fine when communicating only with people in the same country, but our world is becoming more interconnected as we speak, and when documents are traded between these incompatible encodings, all havoc breaks loose. These concerns led to the formation of the Unicode Consortium in 1991 to create a single encoding for every language in the world. It is thanks to Unicode that today Japanese hentai can be seamlessly viewed by computer users in America. But it didn't get that way overnight. Early versions of Unicode required existing software to make significant changes in order to adopt it, potentially even requiring large-scale rewrites. Nevertheless, it was still considered so valuable, Microsoft had Unicode in their Windows operating system by 1993. But this early adoption came at a price. As many programs, including certain versions of Windows itself, could not be easily adapted to Unicode, Microsoft, as well as many Windows developers, would be forced to support both Unicode and non-Unicode simultaneously. The Unicode Consortium soon released UTF-8, a standard that required minimal changes to existing code, if any. But it was too late for Windows. Windows developers would be forced to frequently convert between the competing standards, exactly the kind of scenario Unicode was intended to prevent. Microsoft's own .NET does these conversions too, causing problems on Windows 95 as it is simply too old to know what UTF-8 is. However, since the string is simple ASCII and UTF-8 is fully backwards compatible, the conversion can be switched over with no consequence. Luckily, this solution was relatively simple, but it could have been much worse, and it's just another consequence of Windows Unicode. We can only hope that the world of international communication continues to become more harmonious.
Well, now that we've worked that out, it should just work, right? Yeah, about that.
I'd finally figured out all the DLLs, but was still getting vague, cryptic errors I couldn't trace. By this point, I started testing my work on a clean Windows 98 install too, since .NET should have no problem running there. Yet, I was seeing the same error. Clearly, my installer is missing something, and honestly, that's not hard to believe. I mean, just look at the original installer. Look how much stuff it's doing. Who, what, where, why? I had no idea, and it was no use staring at it and hoping I'd catch everything. I needed to dig into this installer and see exactly what it was doing. I don't really like musicals. Nothing against them or anything, I just don't really see why someone would start singing in the middle of a video. It feels like it would throw off the pacing, you know? Anyway, where were we? So let's talk about this installer for a second. I've already mentioned how it won't run out of the box on Windows 95, however, if you unpack it, you'll find it's centered around a bog standard MSI file. If you're a Windows user, you've almost certainly seen these before. And hey, shouldn't we be able to run that directly as long as we have the Windows installer framework installed? Well, apparently, no. for some reason it insists that we run it from the EXE, the one that doesn't run on Windows 95. Okay. Now, as I said, I wasn't originally planning to use this installer anyway, I just wanted to see what it did. But then I learned that Microsoft has a tool called Orca that can not only view, but also edit MSI files? Maybe I don't have to make a new installer from scratch, let's check it out. This tool is only available in the Windows SDK components for Windows installer developers. Okay, let's install that. Now, generally the Windows SDK components are installed automatically with Visual Studio, but for some reason you can't actually get Orca this way. You have to download a separate SDK installer, which will almost certainly refuse to run because it'll detect the SDK you already have from Visual Studio. Great. So here I go uninstalling those, which was its own little maze because apparently I had 2 SDKs installed. Yeah, somehow having 2 SDKs wasn't a problem before, it's just this moody fuck that can't handle it. Finally, I can start installing the Windows installer tools, but guess what? This still doesn't install Orca. Instead, it just installs the installer. You have to manually comb through your file system to find it. You try to run it and it flashes on the screen for barely a second and you're like, what the hell was that? Is it broken? But no, don't be confused. Orca is now installed on your system. Okay, just one really simple question. What the f was the point of all that? Why couldn't you just put this installer online? You know, maybe here or here? Hell, any of the various places you had to write, you can't download Orca separately. Anyway, Orca can indeed open and view the various tables making up .NET's installer. It's not the most readable thing in the world, but does indeed seem to be everything. But can we actually edit the installer? Let's find out. I managed to track down that check it does to see if it was launched from the EXE, so let's try removing it and see what happens. Wait, apparently that's not all I removed. How is the installer now 1/10 of the size it used to be? In fact, why does this happen whether I make a change or not? Orca just discards like most of the file. My guess is Orca isn't including the actual install files, you know, the stuff we extracted earlier. But that's kind of an important thing to include, and all I'm left with is an installer that doesn't work at all. No wonder they buried this as deep as they could. I'd be ashamed too. Maybe the .NET installer was made in a way that happens to be incompatible with Orca, but you'd think if any tool stood a chance of working with a Microsoft installer, it would be, you know, their own. So yeah, looks like MSI editing is a bust. Back to plan A, recreating. Sadly, I mentioned it wasn't particularly readable, but it's actually even worse than that. This stuff is downright obtuse.
What did you call me?
Like, look at this, I may as well be reading Egyptian hieroglyphics. I was poring over this stuff for hours, just trying to figure out what the hell this was doing that my installer wasn't. And I'll be honest, I'm still not sure I understand all of it. God, I'd rather listen to Russell Crowe sing.
And I'm Javert.
Well, maybe not actually. What I did figure was that I should get all the registry entries ported over. That's usually the other big thing a Windows installer does, and .NET clearly had a lot of them. But I was not prepared for just how many. Welcome back to America's favorite game show, How Many Registry Entries? And we finish today with an audience question. I'll ask a question, and I'll call on 3 completely random members of the audience. If you get it right, you become the proud owner of a brand new Philips Studio! Alright, here we are with the Answertron 5000, here to help us out with this next question. Wow, a lot of excitement for this one. Alright, closing my eyes, no cheating, this really is random. I'm picking you in the hash.
Give me 23.
23! Not a bad guess at all. Best of luck to you. Alright, let's pick our next contestant. You! With the hair.
100.
100! I like it! Go big or go home. That's what I always say. Alright, we need one more guess. One more chance to win the CDI. Gonna be you! In the front.
69.
69! A popular guess, but is it correct? Let's find out. Answertron, show us the correct answer, please. Oh, I'm so sorry, guys, and it was so close, too. Yeah, I don't know why, and I don't want to know why, but that really is the number of entries .NET 2 adds to your registry. It's honestly kind of rude, Microsoft. I didn't ask for this much bloat to be added to my computer.
Why are you so buff? Is it necessary?
It's like some kind of cancer seeping its tentacles all over your system, but I have to assume they exist for a reason, so off I went adding them to my installer. Obviously, processing thousands of registry entries by hand would be a waste of time, so I wrote a script to translate from Orcalang to the install system I was using. Yeah, Orcalang, that's about how understandable any of this is. Was that the missing piece? No. It probably helped, but we were still missing one thing. Something that I actually didn't get from poring through Orca tables. Remember when I said I wasn't going to figure anything out by just staring at the installer? Well, I figured this one out by just staring at the installer. I noticed it spent a decent chunk of time installing .NET assemblies, and I was like, well, how's it doing that? What does that even mean? Well, it turns out one of the core components of .NET is the Global Assembly Cache, or GAC.
What is GAC?
The GAC is supposed to be a smarter alternative to just dumping DLLs in the Windows folder. The GAC keeps track of each library and each version, so in theory you can have multiple versions of everything and apps will automatically link to the right ones every time. It's actually a pretty good idea. The GAC is stored in C Windows Assembly, and on Windows 98 they perform some black magic to actually get it to list the libraries and versions. In reality, it's just a bunch of folders with confusing names that our installer was going to have to recreate. But how? MSI installers, as it turns out, have built-in functionality specifically for installing stuff into the GAC, but NSYS, which I was using, does not. What I found was back in .NET 1, there was a tool called GACutil, which let you install stuff from the command line. I don't know why this was seemingly removed by version 2, but it still works, so I should just be able to call it from my installer. On Windows 95, GACutil didn't quite work out of the box. It actually needed a few more system calls. What didn't help was at one point it started giving me very contradictory information. Yeah, a real task failed successfully moment. Once again, my logs helped a lot in figuring out what it was at least trying to do, and eventually I finally had it installing the assemblies correctly. Windows 95 doesn't handle that fancy listing magic in Explorer, but 98 does. In fact, with all of that, .NET now works perfectly on Windows 98. I think I've officially faithfully recreated the .NET installer, which means any problems we run into now must be exclusively due to differences between 98 and 95. And yes, there were more problems, but I was way too deep in to turn back now. The roles were cast, the stage was set. Now, what the hell is an unhandled exception? Every night I watch the city get worse. Dirtier, noisier, sleazier. The rich get richer and the poor get poorer. Look at these people, they have no idea. They haven't stared into the depths of the city's underbelly like I have. Blown capacitors, corrupted save files, rotting PS3s full of cockroaches. I've seen it all. Nothing surprises me anymore. To feel something you need a soul. I think mine's pretty much all gone. I really need a vacation.
Yeah,
Hey, there's a woman in the office to see you.
tell her my hours are 8:30 to 6.
It's about Windows 95.
I'll be right there.
The murder of Windows 95. The first time I saw this city for what it really is. It's over 20 years ago, Mr. Crabtree entered my office to report a hit on 95, but we didn't act fast enough. All that was left was a small trinket, cleaned of all fingerprints, a calling card we never saw again. I was just a rookie back then, but I've never gotten over it. Let's see what this is all about. Alright, well, strap in. We're about to get really into the weeds here, because this is where I was stuck for the longest. Remember back in Act 1 when I said any normal app we'd be done by now? Yeah, so .NET says an unhandled exception occurred. It provides no other information apart from a cryptic sequence of hex numbers and an offer to send the exception to a just-in-time debugger, which would be great if, this wasn't Windows 95 and there actually were any just-in-time debuggers. Yeah, remember, .NET is not like regular code. It gets compiled just in time as you use it. And actually, one of the benefits to this approach is that since .NET compiled your app, it can actually pretty comprehensively debug it as well. Which makes a cryptic error like this even more frustrating. Debug yourself, you fucking coward! I guess it's happening too early for any of that infrastructure to be available, so okay, fine, I'll play it your way. And by your way, I mean I have no idea what way. I had so few helpful tools available on Windows 95, and it's not like I could use any other OS because then I wouldn't be having this problem. The only thing I could think to do was use a regular machine code debugger. While .NET code is not machine code, it does eventually become machine code, and maybe looking at that would give me a hint as to what was going wrong. Let me tell you, this process was pure torture. Just imagine trying to set breakpoints on code that doesn't even exist yet, and you'll get an idea of how frustrating this was. It didn't help that the only debugger I could find that still supported Windows 95 was this piece of shit geriatric version of Let me tell you, I hate this thing. I'm sure someone out there will tell me I was just using it wrong, but I could not get this thing to cooperate. You'll see what I mean later on, but all I'll say now is I wish I could have used something else. But the pickings were slim on Windows 95.
It was not by my hand that I'm once again given
Windbugger.
Luckily, the first exception happened before any recompiled code, so it was fairly easy to track down. But that didn't make it any less confusing.
Windows 95's murder didn't just shock the nation. It left behind a devastated widow, a woman I hadn't seen for 20 years. Anyone who knew her knew she adored her husband. I hear she still grieves like it was just yesterday. I'm sorry we never found anything.
Well, maybe this will help. I found it while cleaning. It's addressed to me, but I don't know what it means. I thought maybe you would.
No, you haven't suddenly contracted an acute case of dyslexia. .NET really tries to load a file called this. It's a VXD, which is a device driver from early versions of Windows. Remember when I said Windows 98 introduced a new driver model? Well, this is what it upgraded from. So, just one small question. Why in the name of is it trying to use a driver for an OS it doesn't even support? And what could it possibly need a driver for anyway? Aren't they usually for hardware? I've tried looking this thing up, but there is literally nothing about it online. The only results are just people listing the files that come with .NET. No attempt to figure out or explain what it is or does. Maybe if it wasn't called Nudfulpur, I might at least have a chance of guessing what it means, but no. Anyway, .NET tries to load it and Windows returns a file not found error. I mean, it is there, I can see it in the system folder, though you may notice .NET doesn't try to load it from the system folder. What's this slash and dot pattern at the start of the path? Well, apparently this is a DOS device path for loading DOS devices, I guess, and is apparently the correct way to load a VXD. So why doesn't it think the driver is there when it clearly is there? Well, truthfully, I don't know. Seriously, I never figured this out. I mean, maybe I was supposed to install this driver somehow to let Windows know it existed, but I couldn't seem to find any information about how or if I should do that, and besides, Windows 98 was fine with my installer. It didn't seem to need anything like that. I even tried reading this old book specifically about VXD drivers until it became unreasonably popular for some reason. I even loaded the driver into Ghidra on the off chance I could see what it was trying to do, but this stuff was too dense even for me. I had to get some more information, so I wrote some code that would log all of the communication between .NET and the driver on Windows 98. This way I could at least see when and where it was used, which must be a lot if it refuses to run without it, right? Well, after all of that, guess how many times I saw .NET and the driver actually talk? Once. One time. On startup, .NET sends this number.
Yeah, I'm sick of this!
And in return, the driver sends back the hex number 40. Wow, Riveting conversation. I've seen couples on Maury Povich with better communication skills than this. But you know what? If this is all it is, then why don't we just patch this shit out? We don't need a driver, I'll just make the easiest hardware emulator ever written.
May I use my VXD? No.
So basically when .NET tries to load the driver, I just don't and say I did. Then when it tries to send the driver that number, I send back the all-important 40. I even show an alert if .NET happens to send anything else, but so far I've never seen that happen. And I'm still no clearer on what any of this is supposed to mean. But you know what? It's happy, and that's all that matters. It just doesn't look like it yet. Yeah, believe it or not, we're now onto a different exception. Can you tell?
With all this talk of code, I figured I should check out Windows 95's computer. We'd taken it in because it had blood and fingerprints on it, but according to the report, no one ever checked what was on it.
Windows 95 had a Mac?
Yeah, I know, right?
Dear Nancy.
Dear Nancy, if you're reading this, I'm already dead. I've been involved in things I shouldn't have been, and now it's too late. I signed my death warrant as soon as I got involved. My killer should be brought to justice, but I'm being monitored too closely. I've left an instruction at the bottom of this letter that I hope will help you find them. What the hell kind of instruction is that?
This time we're in deep Dynarec territory. All code from now on would be generated on the fly. That means debugging will be more complicated and we have no Ghidra to fall back on anymore. That being said, whatever exception this was did seem to correspond to a machine code exception that WinDebug could catch. Too bad it couldn't do anything else with it. Yeah, this is when I started having a lot of trouble with WinDebug, and to be honest, I'm still not sure if it was a problem with it or I just couldn't figure out how to do what I wanted to do. Apparently later versions actually natively support .NET code, but not this one. It would catch the exception, which basically means the whole thing would pause so I'd have a chance to analyze it, and I'd open the call stack to see how we got here, but every function listed here is just code that passes the exception to the operating system, not the code that caused the exception to begin with. Okay, well, maybe the dynamically recompiled code is throwing it off, so I thought maybe if I handled the exception myself, I could step back to at least somewhere around where it was thrown, but all the stepping functions were grayed out. In fact, it explicitly said the only thing I was allowed to do was unpause the app, which would obviously cause it to blitz right past the code I was trying to find before I could possibly pause it again. The documentation seemed to back that up, that unpausing everything was the only way I could respond to the exception. I just couldn't find any other option or any other way to get the information I needed. Nothing in the help and definitely nothing online. The only thing I could think to do was the dumbest, brain-dead, brute force approach possible. I would load up the debugger on Windows 95 and Windows 98 side by side and step through each one instruction by instruction until I figured out what Windows 95 was getting wrong. Yes, this was as laborious as it sounds. Yes, I was doing this for days on end. It's easy to take for granted how quickly computers, even back then, blitz through this stuff, until you have to read through it all yourself. And if I made a mistake and let one get ahead too quickly, I'd have to painstakingly reset it and get it all the way back to where it was before. Remember, the code I'm debugging gets compiled as the program runs. I can't just set a breakpoint at the beginning because it doesn't exist yet. I cannot overstate how much this sucked, and I wouldn't wish it on my worst enemy. Though, I'd still rather do this than listen to Russell Crowe sing. Yet somehow, as dumb as this approach was, it actually did produce results. After several days, I eventually arrived at this. Instructions so illegal, I guess, that even WinDebug didn't know what to say. So what is this? What could it be trying to do? Yeah. Mrs. 95. What can I do for you?
I'm so sorry to bother you. I just wanted to see how the case was going. Did you get anything out of that code?
Yeah, we learned it was an old code. Something called,
X86.
X86. Something we made back in the 70s and are still somehow using today.
X86. I seem to remember we had a book about that somewhere.
Really?
Yeah. Do you want me to bring it to you?
Now, how about I come to you? See if you left any other clues behind.
Sure.
We'll be there soon. This is 95. Yes, the reason why WinDebug, and Windows 95 for that matter, couldn't understand this instruction is it's an SSE2 instruction. If you don't know what SSE2 is, it's some shit Intel added in the year 2000. Naturally, Windows 95 wasn't around for this. In fact, neither was Windows 98. But 98 does support the first SSE, and since SSE2 uses all of the same registers, those instructions can get away with running. Clearly, because I've been running this in a virtual machine, it's looking at my actual CPU's features, as anachronistic as they are. So what does this SSE2 code do? Well, if we disassemble the bytes with a more modern tool, we can see the instruction is, oh, obviously, right? Okay, it's obviously an acronym for something that will surely make total sense. Ah yes, of course. It converts with truncation scalar double precision floating point value to signed integer. You get all that? Which is just a long way of saying it does this. The good news is there are ways of doing this without SSE2. I guess they're just a little bit slower, and .NET should have a fallback to do so. I mean, even in 2005, not every computer had SSE2, especially not everything running Windows 98. Indeed, .NET does have code that checks if the CPU supports SSE2 or not. And funnily enough, even Microsoft seemed to be aware that just because a CPU supports it doesn't necessarily mean the OS does. It does a secondary check where it actually runs an SSE2 instruction, and if it fails, it ignores what the CPU said and doesn't use it. So, what's the problem then? Why is it still trying to use SSE2? Well, here's the problem. It turns out they do this double check everywhere, except for here, where they don't. Cool. Remember when I said we wouldn't have to edit any of .NET's code? Well, it turns out that we do, to patch this one usage of SSE2 out. And once I'd figured all that out, I saw this glorious sight. Whoa! I got you. I got you, son of a bitch. Well, if we're getting this far, we can be reasonably sure that all of the back-end stuff is working properly, but what the hell is this? Another unhandled exception? Looks like .NET's debugger is finally kicking in, but for some reason I still can't get any information about what's causing these things. So close, yet so far, right? Upon closer inspection, it seems like interacting with the UI in almost any way throws this exception, including pressing any of the buttons to, show me the exception. Great. The WinDebug process, as annoying as it was, had been producing results, so I went back to it again to figure out what was causing this. But this time, it really was impossible. There's just too many layers of dynamic recompilation in by this point. I just couldn't seem to get anywhere near it. After even more hours of wrestling with WinDebug, I finally decided it was time for some lateral thinking. I figured I might not be able to interact with the UI to get the exception, but I can probably at least get it to show on the screen somehow. I found pretty quickly that I could simulate a button click in C# and that would throw the exception too. So I just wrapped a try-catch around it and got it to print whatever exception it got to the screen. Amazingly, this actually worked and I could finally see what was wrong. Predictably, .NET was trying to call another missing Windows API. Yeah, we covered all of the APIs that .NET uses to run .NET, but it's pretty trivial to write C# code that calls machine code functions, so it stands to reason they did that too. But from here onwards, this stuff actually got really easy. As we learned from Sonic Runners, .NET is very easy to decompile. In fact, C# is actually designed to map very closely to the intermediate language it compiles to. That means that, unlike machine code, converting between the two is a fairly trivial process. So with a tool called dnSpy, I could just edit those calls to Windows APIs and either point them to my DLLs or just remove them entirely. Soon I had the old version of Rebuilder working exactly as it was meant to, as well as other .NET apps I'd written like this one that replicates the WinShift-S screenshot functionality from Windows 10. It's actually kind of surreal seeing this stuff working so well after all of that. I mean, that was the goal and all, I just got so used to there always being another problem. I can imagine there's still some C# code calling system functions that 95 doesn't have, but as I've demonstrated, they should be super simple to resolve as they crop up. In fact, we can actually take this a lot further. Turns out, .NET used the same runtime, the thing we just backported, all the way up to version 3.5, which saw even wider usage than the 2.0 we've been focusing on so far. 3.5 only ever supported XP and up, but with this backported runtime and the same C# editing technique, we can get it running on 2000, ME, 98, and yes, even 95. So yeah, I think we can officially say .NET has been backported to Windows 95.
Take him away, boys. Mrs. 95's tip paid off. We unscrambled the code and it let us write to him. He left behind enough evidence he'll be an open and shut case. He'll be going away for a long time, and in a funny way, so will I. I'm finally taking that vacation.
So we've been on a bit of a journey together, you and I. And on a big journey like this, it's easy to get so stuck in the weeds and the nitty-gritty of every little thing that you forget about the bigger picture. Why? Why backport .NET to Windows 95? Sure, the abstract is clear. We get a little more software running on an older operating system. But who cares? Who cares about running things on Windows 95 or 98 or ME for that matter? Well, me. Obviously, I'm not regularly using any of them today, but some of my most formative memories were made in this clunky, boxy world. I didn't really grow up with a lot of games or game consoles, but we had a computer, and with the kind of patience that you only have as a kid, I figured out things to be excited about. Just like watching movies and YouTubers would inspire me to make my own videos, I would use computers and be completely in awe of how people could come together to make an operating system. Little things would fascinate me, like how do they use dots on a screen to make something look like it was 3D? It inspired me to try writing my own code and making my own icons. I would spend hours trying to make stuff even close to what I was seeing. We talk a lot about preservation nowadays. Video games and software in general is in a uniquely tough situation because more than any other art form, it's tied to the medium it was released on. And more often than not, it's just not financially viable to change that. Imagine if the only way to watch an old movie on a new TV was for the crew to go back and refilm half of it in 4K. I mean, that didn't stop George Lucas from trying, but you get my point. Sure, an operating system is more of a tool than a work of art, more of a butter churn than a Michelangelo, but that being said, it's also something that was designed to connect with people, to make this cold metal machine feel like it was actually friendly and approachable, and it connected with me and helped inspire me to make things. It's a big reason why I do what I do today. Preservation isn't just being able to use something. It's not just about having a virtual machine or an old computer lying around. It's also about what we can do with it in the modern world, how it can take advantage of modern technologies that we couldn't have even dreamed of back then. There's a reason we want to play GameCube games in HD, watch movies in 4K, listen to music digitally instead of on cassette tapes, because these things matter to us and we want to see them at their best. Backporting.net is a tiny, tiny drop in a very big ocean, but what kept me going was thinking of what we might be able to do with it, all the ways we could hopefully keep this old stuff alive.
Preserve the software. Idle message. Goodbye.
Hey, thanks for watching and waiting for this ridiculously long video. I want to give a huge shout out to my patrons scrolling on the screen right now for really keeping me going through the making of this video and supporting me even though I wasn't uploading as much. It really means the world to me, so thank you guys. Speaking of Patreon, I have a lot of Patreon exclusive content coming up, including a more technical deep dive into the .NET backport, some behind the scenes on this video, and I have a poll up right now for what project I should do next. Whatever gets chosen, I'll be posting regular Patreon video updates detailing my progress, so if any of that interests you, check it out. Anyway, thanks again, I hope you have a great day, and I'll see you all in the next one. Hopefully it won't take this long again. Bye guys. Oh yeah, and the Lego Island decomp is going great.